right. Good morning, everyone. Hope you all had a good weekend and are ready for the week this week. Just to give you a little update on where things are logistically in this class. I have barely touched grading assignment 2, to be perfectly honest with you. I had a very busy week last week, crazy busy. So just did not get as much time to spend on that as I wanted to. What that means is that it's definitely a priority for me this week. So assignment 2 is going to be graded this week. That is for sure going to happen this week. It's not nearly as busy as last week was for me. So I will have plenty of time to get assignment 2 graded. That'll happen maybe even by the time we meet next on Wednesday. So then that is, of course, when assignment 3 is due. Yeah, I know that's kind of a tricky assignment, probably the trickiest one I've asked you so far, so be sure to hit up office hours. I do have some availability later on this week. If you need an extra day or two to come chat to me about it, that's totally fine. Or even if you just need an extra day or two and you don't need to chat with me about it, that's also totally fine. It's not really going to bother me. I probably won't even get around to grading assignment 3 until next week, so I hope it's going well for you. I hope you're able to get it submitted on time, but don't feel bad if you need a little extra time to get that assignment in. Yeah, I think that's all I have to tell you for now. I guess one quick logistical note. I will be out of town next week. So on the 25th and 26th, I will be out of town for actually the 26th and the 27th, I will be out of town for a conference. I'll be in Pittsburgh. So we will not have class next Wednesday. I'll be out of town. I won't be here. Yeah, we'll pick up where we left off when I get back. It's just that one day that I will have to miss. Okay. So today is kind of wrapping up our conversation on clean code, and we're gonna wrap it up with a very important topic. We're gonna talk about objects today. So objects are sort of the last thing that students get introduced, not sort of, but they pretty much are the last thing that students get introduced to in 131. They get a few weeks of practice, but I think it's important to understand just how useful they are and how prevalent they should be in your code. It's almost a little bit misleading if 131 is the only class that you've taken, right? We actually spend the first 2/3 of the semester not using objects really in any way, shape, or form. Actually, there's a name for what that's called. That's more what we would call procedural programming. So when we're just using functions or methods, we're not really using objects at all, or instance variables, or anything like that. That's more of a procedural style. It's still very valid style of programming, but it does kind of have its drawbacks. Actually, what we have been working on in class these last few weeks, on Wednesday when I refactored all this stuff into functions or into different methods, this is more of a procedural style, and this is kind of how we teach our students in 131 to do methods at first before they know what objects are, right? It's still kind of has its place. It's still a very valid way of programming, but objects really can go a long way towards helping you organize, helping you categorize, helping you keep your code clean and easy to understand and easy to work with and easy to modify, change, add things to, etc. So the whole purpose behind an object is this idea of abstraction. I'm going to take some details, some information about the thing that I care about, and I'm going to hide it from you, right? A lot of times the instance variables are not readily accessible to you. If you remember from 131, we always mark them private, 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 private. If you know about inheritance, then yeah, there's an exception to that rule, but even still, we keep everything locked away, and then we provide methods that manipulate that data when we need to based on the behavior of our objects. That's kind of the whole idea behind object-oriented programming, but why? It might seem a little bit unnecessary or unclear as to what the advantage is of hiding those details away. Well, I often like to make the analogy of driving a car. I drive a car all the time. I could not tell you how an engine works. That's just not a thing that I know about. Maybe some of you do, and that's great. I know there are people in the world who know how engines work, and I'm very glad that they do. But in order for me to drive a car, I don't have to know how the engine works. And I like that about cars. That is a good thing about cars, right? That is a very practical, real-world example of something that is hidden away from us. We know how to interact with it. I know that if I push the gas pedal, car goes vroom vroom. If I push the brake pedal, car stops. But I don't need to know every single thing that happens when I hit the gas pedal, right? That's not necessary for me. I just need to know the car's going to go. So that's kind of how we want to approach our code as well. Think about, as you design an object, what should the outside world know about this object? That's what you're exposing via your methods. And then, of course, we also have the classic getters and setters that we teach everybody about when we're dealing with objects, how to access instance variables using getters and setters. I think that's another very important concept, and one that I hope you take seriously. It's very easy to get in the habit of just blindly adding getters and setters into your objects, but really that should only be done with careful consideration, making sure that you have a justified need to expose that data, because we want to try and keep as much of it under the hood as possible to keep our objects as simple to use as possible, both for us and the other people that are going to be using that code. So let's talk about some rules regarding our classes and regarding our objects. I'm going to open up some notes here. I think it's useful to talk about some, just like we did for functions and naming, I think it's useful to talk about some useful kind of general rules of thumb for classes and objects. And it may come as no surprise to you that just like we saw with functions last week, we want to keep our classes small. We really want classes to be small. So how small? That's the question. And last week, when we talked about functions, I introduced you to this idea of the rule of 20. And I think that's this is another application of that rule. So we would say that a class should have no more than 20 instance variables, and also probably no more than 20 methods as well. And I would say that when I say no more than 20 methods, that probably doesn't include things like getters and setters. That probably doesn't go towards that cap of 20, right? And even still, remember that just like with the rule of 20 with our functions, that's the upper bound. We don't want, that's not the goal. We don't want to pad our objects to have 20 things, right? If we can get away with less, we want less. This is the max. This is the upper bound that we're willing to accept. This is a line where when it's crossed, we're going to think, we need to figure out how to split this up somehow. Maybe there's another object in here somehow that I can extract out to keep all of this separated and more organized. So we're really going for brevity. Think of it like a toolbox. So we want to have lots of small compartments, lots of small drawers in which to put our tools, as opposed to one big giant drawer that everything's thrown into. That's kind of what we're going for. All right. There's plenty of conventions about classes, how they're laid out. So I think some of you are probably already aware of these things just from even 131 or just working with classes in general. But at the top of the file are always going to be our instance variables. So instance variables come first, and these are almost always going to be marked private. In fact, the only exception to this rule would be if you're using inheritance, in my opinion. Otherwise, they are marked private. There's no reason to ever mark them as public. We'll use getters and setters, public getters and setters, to provide access to our instance variables if that's what we need to do. But after our instance variables, then we're going to stick our constructors. And we can't have more than one, right? So if I have more than one constructor, I typically want to see all of them right up at the top of the file in a group. And then after that, we're going to put public functions, or public methods is probably a better way of saying it, since we are talking about Java. these are the methods that if I am trying to use this object, these are the methods that I will be able to use. So I wish to list those first. The private methods are probably not going to be accessed by me, right? They're usually only internal for use within the class. So those are going to come afterwards. Anything that's private. And then even though they are in fact public, getters and setters usually come at the very bottom of the list, in my opinion, because they are typically so trivial and straightforward that I honestly only really need to know whether they exist or not. I don't need to see the code. So I don't necessarily include those in the list of public methods, even though they often are public. Now, this is somewhat influenced by my own opinion. There are other people who might switch this order slightly or put things in slightly different places. And if you're getting paid to do it, then you better pay attention to what your job says you should be doing, right? Regardless of what I'm telling you to do in this class. But this is something you will be graded on in the project, and something that I'll definitely look for when I'm going through and peer reviewing your code on the final project. Great. Let's talk about a few other things that we care about in regards to using objects and creating objects. One big thing that you'll hear mentioned a lot when creating classes is this idea of the one responsibility principle. An object should be responsible for one thing. Should do that one thing, should do it well. Should not worry about doing anything outside of that scope. So this is a way to kind of check yourself and make sure that everything that is in that class is related to the class itself. And the way that this is often done is by using those phrases. I introduced these phrases again in the intro class in 131 when we first talk about objects. For instance variables, we want to make sure that there's a has a relationship, right? So for instance variables, I would say a person has a name, a person has a birthday, a person has an address, right? If I can say it like that and it feels natural, then that means it's in the right place. If I say, something that doesn't make sense, a person has wheels, not really. Okay, now we can start to think that there's another object in here then, right? If that's not part of a person, then what object is it a part of? We need to figure out what that object is and move it out of this class into whatever that new object is. And then for the behaviors, right? Or I'm sorry, I kind of got that backwards. For the methods, those represent the behaviors of the object or what an object can do. And you can use this same kind of logical test to help you decide whether the methods are in an appropriate class or not. People can walk, they can talk, we can do lots of things, right? Can you drive a person? No, that's typically not a behavior that you associate with people. That's a behavior we associate with vehicles. So if you see behavior that doesn't match what the object is telling you it is, that's another clue that, hey, there's another object here perhaps, right? It needs to be extracted out. This behavior needs to be moved to that object. And then finally, another thing to keep in mind when we're using objects, we want to try and keep our coding concise when using objects, and a good rule for that is the law of Demeter. The law of Demeter is trying to help us avoid, you've probably seen statements like this. We can use the dot notation, right? To say something like this thing, do a thing, parentheses, do another thing, right? Get results. So you can chain all of these things together, right? maybe you haven't seen this before. Maybe I am, spoiling your innocence a little bit by showing you something like this. Maybe you have run into this before. I think everybody does sooner or later. This is honestly a pretty mild example compared to some things that I've seen and honestly written before, right? I'm not innocent myself. I write bad code. Everybody does. It's not our job to get it perfect the first time. It's our job to get it perfect eventually. So, while this can be a quick way to get done whatever you're trying to get done, this is terrible from a code readability perspective. It makes lines super long. At the very least, it should be broken up into multiple lines and separated out. But the law of the meter tries to take this a step further to kind of really limit not just how much chaining we're going to be doing, but also try to limit the focus of the method itself. Keep the focus of the method within the object to a somewhat limited range, so that we're not trying to overreach and depend too much on stuff that's happening in other classes. And so that's where the law of the meter comes in. It says that where's my cursor? It says that if I am for a method f within a class C, right? So if I have a class called C, and within that class there's a method called f, the only methods that can be called within f are methods within C, so methods within the same class. So if I am a method within class C, I can also call other methods within class C. That's totally reasonable. That's totally fair game. That's not an unreasonable thing to expect. I can call any methods on an object created by the function that I'm currently in. So if I create an object within a method, I can call methods upon that object that was created. That's what the second rule says. The third rule says that if there are objects passed in as arguments to f, so if there are parameters to the method and an object gets passed in as a parameter, I can call methods upon that object. And the last category is an object within an instance variable of the class that we are currently in. Trying to see if I can fit all of this on the screen at once. There we go. This is the law of the meter. There's 4 points. Again, we're saying that if I'm creating a method within a class called C, the only methods that I'm going to call from within the method that I'm writing are other methods within the same class, methods upon objects that I have created within that method, any objects that are passed in as parameters or as arguments to that method, and then any objects that are an instance variable of the current class. So think about what that means. That means that something that you should not do, or that you should try to avoid, right, is what if I say, object is x.getThing, right? So I retrieve an instance of an object from x. Maybe x is a parameter, maybe x is an instance. That falls within our category of things that I can do, right? I can do this. This is fine, but I cannot then call any methods on O afterwards. So calling any methods on that object that I've stored in that variable O would not be allowed under this rule. Does that make sense? And the purpose is, again, is to kind of limit how far our methods are reaching out. By limiting how far our methods reach out, we hope to keep them focused on one thing. What if I really do need to call a method on that object? What if I absolutely need to do that? Well, I can always return that object, right? Or I can always tell X to try and manipulate that object somehow, right? I can see that it originated from whatever I'm calling X. So maybe X should have a method that allows me to interact with O in that way. It's hard to say what the proper answer is without looking at the actual example and evaluating all of the factors involved. And again, I'll be honest, right? I've broken this rule. This isn't a rule that I'm constantly thinking about as I'm writing code. It's one that I'm thinking about as I'm cleaning up code. And if I ever see, especially if I ever see a dot statement that's more than 2 dots, that's my immediate red flag to look at that and be like, all right, how can I try and reconfigure this so that it follows the law of the meter? That's a pretty big flag that I'm not following the law of the meter. If I'm using any statements that have more than 2 dots chained together, like that big chain I showed you a moment ago, chances are that you're probably violating the law of the meter. So take a look at that chain, see if maybe one of those objects needs another method, maybe the class you're currently in needs another method, maybe there's something else you can do to rein that code in, make it more focused, and keep things more organized. Because that ultimately is our goal. Clean code, clean organization. Cool. The next thing we're going to do is, like we've done for the last few classes, is switch over and try and apply these concepts to some actual code. Does anybody have any questions before I do that? Any questions about what we talked about so far? Yeah. So this isn't calling an object on a method created within the function, right? Calling an object on a method created within the function would mean calling a constructor. So if I did this, new object, right? Now I can call stuff on O. I created it within the function. But this object, this instance that I'm getting back, was created somewhere else. This is not a constructor, so it was probably created within X, whatever X is. This is an arbitrary example, so it could have been created in a bunch of different places, but was not created here. I got it from somebody else. Yeah, good question though. Any other questions I can address before we take a look at some real code examples? Yeah.
So could you instantiate O with a constructor in these methods?
Correct. Yeah. If you are calling a constructor within the function, you can then call methods upon that instance that was created within the same function. Yes. That is acceptable under the law of the meter. Yeah. Great questions. Any other questions I can address before we switch over to Eclipse and look at some code? Okay. So I know that not a ton of you were here last Wednesday, and I don't mean that to try and brag on anybody. It was a crappy day, so I completely understand. The reason I'm bringing it up is because I want to make sure we're all kind of on the same page when we start on these examples. So I saved a copy of my stuff from last Wednesday to a branch on the repository. So if you have, if you've already cloned the naming repository, it's the same repository that we've been using the whole class, this naming repository. If you've already cloned it on your machine, I just pushed a new branch just this morning, just before class. Oh yeah, you can actually see, yeah. Just before class, I pushed a new branch. It's called Objects25. So if you are on the command line and you want to, get that branch, the first thing you're actually going to need to do is, whoa, what happened here? Let me just get a fresh screen. First thing you're going to need to do is pull, right? First thing you're going to need to do is tell GitHub, hey, send me any new stuff, because chances are you don't have the stuff that I just pushed 35 minutes ago. Maybe you already pulled, but first thing you're going to need to do is pull, and then the next thing you're going to want to do is perform a checkout on Objects25. I'm already on that branch. That's why it's complaining to me, I guess. But let me know. You'll be able to, you should hopefully see the exact same code that I'm looking at right here, which is the refactored code from last class. You can also see it on the video that I posted of last Wednesday's class. The two examples I'm going to focus on actually are the dice and the gambler's ruin examples. We refactored these into methods last time, but not objects. And I have a few goals for today, actually. So a lot of the goals that I have for today involve determining what the objects actually are. But also, these methods, you may have noticed, are all marked static. I've already kind of talked about this a little bit. Static methods are an indication of more of a function than a method. It's an indication more of procedural programming than object-oriented programming. And I tell all my 131 students this as well at the end of the semester. We start with static methods, but then as soon as we use objects, as soon as we learn about objects, those static methods are pretty much gone. I don't want to see static methods anymore. The one very notable exception, of course, is main. Main is always going to be static. We need main. Main is the entry point to our program. It's not going anywhere. But otherwise, most of the methods that I write are non-static. Occasionally, I do have a justified need for a static method. It's an every once in a while kind of thing. The default should be non-static. And that's because we want to rely on our instance variables. We want to rely on our objects. Recall the difference between static methods and non-static methods is actually, can they access instance variables? Static methods cannot access non-static instance variables. They do not require an instance of an object to operate, whereas non-static methods require an instance of an object. Right? They must be called upon an instance of an object. That is one of the most complicated topics actually that we cover in the intro class. So if you're fresh out of 131 and this is kind of a review for you, this hopefully is a good review for you to reinforce that idea that we need to create instances of objects and call methods upon those instances. That's good object-oriented programming. And right now we're not using any objects in this example. I'm looking at the gambler's ruin one. So I want to figure out what objects exist. I want to make any methods, non-static. And then another sort of side goal that I have is to make this main method as small as possible. Main method should be tiny. Main method, and when I say tiny, I mean a couple lines. Maybe call a constructor and then call a method on that object. Done. Right? Should not be anything more than that. We want our objects to do all the lifting. We want our objects to do all the work. Main methods should be absolutely tiny, and that's another thing that I will definitely look for when we get to the project phase in a little bit. I know 131, we start you out doing everything in main, but now that we're more professional programmers, we got to break that habit. Main should be tiny, put everything into the methods within our objects. So really, I think there's only one object that I can think of here for this particular example, and it's not super intuitive what that object is. Remember, objects should be nouns. Objects should be nouns. And so I'm looking at this gambler's ruin one where, I go down to the casino and I flip coins all day and decide whether I make enough money or not, and it's like, what's the object here? What is the noun that I can use to describe this? I would say that try to think abstractly, right? It's not necessarily the gambler or the game, although those are nouns, right? Perhaps you could create objects for those things, but the big important one that I think is absolutely necessary is the simulation. The simulation itself. So the simulation itself is a noun, right? I'm doing a gambling simulation, essentially, in this code. That's what I would actually prefer for this object to be called. Gambler's Ruin is the name of a famous, logic puzzle / problem, but if I'm trying to follow good, clean coding guidelines, I'm probably refactoring this and calling it a gambling simulation. So Eclipse will let me do that. It'll even rename the file for me, which is necessary. I think that's another thing that can often be overlooked. The name of the class has to be the same as the name of the file that contains the class. That is a rule that Java enforces. You'll have files running code if that is not the case, and Eclipse will complain about it as well. But now that we've decided upon, what this class should be, we got to think about, okay, what should the instance variables be, right? What should the instance variables for this class be? And I think if we look actually just down a little bit here, we can see that, oh yeah, right? I see that we asked the users for all these values. These actually should be instance variables as part of our simulation. And we're going to mark them as private, just like we would all of our instance variables. So oops, I misspelled that a little bit. And then the last one was, I don't know if maybe, wasn't there 4? There's chance of winning. Oh, I did chance of winning, maximum amount of days. Oh, start amount. All right. After the instance variable comes the constructor, right? Comes the constructor. The constructor's purpose in life is to set the instance variables. And that actually, we're using the scanner to do this. We're using keyboard input to do this. So a couple of different ways I suppose we could approach this. Do we want to keep, the scanner inside of our class? We could actually make the scanner an instance variable, and that's not an uncommon thing to do if I have multiple things that need to be read in. Remember, I already have these methods for reading in ints from users, so the fact that I have multiple methods dealing with the scanner also kind of tells me that, yeah, maybe I do need scanner as an instance variable as well. So, okay. Not an int, but a scanner. And now now that we've tackled the instance variables, we're gonna take a look at the next one, which is the constructor. Recall from our intro conversation on object-oriented programming, right? Constructors don't have a return type. They have the same name as the class itself, but the role of the constructor is to make sure that all of these values get set. So we have to decide where these values are going to come from. And it seems to me as though we can create the scanner directly, right? So I can say keyboard input equals new scanner system.in. And for the rest of them, we had those methods. It's actually, while perhaps not the way you saw me do it in 131, if you took that class with me, still very possible to call methods from within the constructor, especially if we need scanner input to make that happen. You might want to argue that this is making the constructor overcomplicated and the scanner should be kept out of this class. I'm trying to play both sides here, right? I think there's not necessarily a right or a wrong. You're gonna have to think about your specific needs, your specific use cases. I'm just trying to show you different ways that things can be done to try and also keep things clean and organized. But let's say we want to reuse the methods that I have from before. We already need to think about how they're going to change based on the fact that we're not doing static methods anymore, but we actually have instance variables. So here I had this passed in as a parameter. The fact that I've made that an input, or the fact that I've made that an instance variable, means that I don't need that as a parameter anymore, and I can make this non-static. So we're already getting payoffs from using instance variables and objects here. Same thing for this one. Oops, I deleted the return type. That wasn't what I meant to delete. We can delete that keyboard input. And now we just need to call these methods from the constructor to set those other instance variables. So I'll try and do it in, oh, actually, it probably would be reasonable to just, I want to do it in the same order. So start them out first. We have to pass in the prompt. All right. And then we'll set the chance of winning. And then we'll do these other two, the max win amount and the number of days. Number of days. All right. And just like that, we've already offloaded a big chunk of work from the main method into the constructor, which makes me happy because that was one of my goals, was to have the main method, you know, not have to do any of this stuff. So we can pull all of that out now. That's all being taken care of in the constructor. And so actually what I want to do in this main method is construct one of these things, right? And then we still have to fix the rest of these methods. Notice that just like with the other ones, we were passing in all these values as parameters. We don't need to do that now. We have instance variables, so we can actually remove all of the parameters from these static methods, which feels so satisfying. And again, helps us. This was another problem that we talked about on Wednesday with our methods, especially regarding the number of parameters. We want to keep that at 3 or less. Here's a very concrete example of how using instance variables can help us achieve that goal of you know, reducing the number of parameters to our methods as much as possible to keep things more understandable. And the nice thing about the way that we wrote this is that I can remove those parameters and that word static, and the code just automatically picks up those instance variables. By making it non-static, it now sees the instance variables, and that's great. Would also need to do the same down here. Play game, while actually it does depend on instance variables, so we need the same thing. Take the parameter out. That's an instance variable now. We don't need that parameter. Make it non-static. And then I think we've actually, yeah, we've made all the methods non-static at this point. What are you unhappy about? Oh, it doesn't want this argument anymore. We removed that parameter, so it doesn't need that argument. And the same thing for these up here. We removed this argument, all these arguments. However, there are a couple of loose ends to tie up. One is we have this total days failed value. Where should that go? I think that's actually probably another instance variable. It's just one that we know the value of. We don't have to ask the scanner for it. Total days failed. We don't have to ask the scanner for it. It just starts at 0, right? I believe every time. And then it will eventually count how many days have failed up here. That allows us to take that out, as well as the last parameter. We don't have any parameters now, which is honestly wonderful. And then the last thing we need to do is recognize that since we made these as non-static, they require an instance in order to operate. The instance that we want is the one that we created up here. So the proper way to call these methods would now be to stick the instance out in front and see what I forgot. Is it still expecting? Did I need to remove another parameter? Oh, yeah. Remove this final parameter. And take a look at our main method now. How tiny it is. That is, wow, that is chef's kiss. Beautiful. Love our main methods to be that tiny. That's what we want every time. If your main methods start to get bloated, I hope you start thinking about, well, which part of the object should be doing this stuff. This method is still a bit long for my liking. It comes in at like just barely, just at that 20 line. I think if I were going to work on this more, that would probably be something else I'd try to target, see if I kind of have all my instance variables, if I can try and extract some more methods out of this big method. But otherwise, I think it looks a whole heck of a lot better. It's maybe a little hard to envision in your brain where we started with this. This would have been a week ago when we first pulled it up, right? Had terrible names. Everything was in the main method. There were very hard to understand what's going on. We have completely transformed this. But notice that it's actually a lot longer than what we started with. Even when it was all in the main method, it was a lot shorter, both in length and also the variable names were a lot shorter. It's part of what made it hard to understand what's going on. That's a trade-off that I will take any day of the week. I am not worried about how much physical space on the screen my code is taking up. I'm worried about if I can understand what's going on. So if that's the trade-off I have to make, I have to spend more writing, more letters, more code, so that I can more easily understand what's going on and what my code is doing. I will take that. I will take that trade-off every single time. That is exactly what we're going for in this class. And of course, you should also not just take my word that everything is going to work exactly the same, but run it. Make sure that it works the way you expect. Here we go. I mean, it didn't crash. Is it working the way I expect? Reasonably, yeah. I'm very familiar with this because it's an old 131 assignment. I know you may not be as familiar with it as I am, which makes it a little harder for you to tell if it's actually working properly, but yeah, I think it is. You can see the simulated rate and the expected rate are in the same ballpark. Good indication that it's working fairly well. Are there any questions about what I've done? I feel like this is one of the most satisfying examples that I get to do in like every single class that I teach. It feels so good. And I'm about to ask you to try this for yourself. I hope you get the same satisfaction out of it that I do. I would like for you to spend the next, 15, 20 minutes talking to your neighbors about the dice example, and I want you to do the same thing that I just did with the last one. Try and identify what the objects are and see if you can clean up this code. Remember, I put this in a branch, so if you're having trouble accessing the branch that I just committed this in, you can always reclone the repo. That's another thing you can do if you're really having trouble with it. But I'm also happy to help you resolve any Git problems, if you're running into Git problems, getting access to this code. But spend the next, 15, 20 talking to your neighbors, refactoring this, adding some objects in there, and then we'll spend the last 15 or 20 walking through it and cleaning it up before we call it a day. All right, we have about 20 minutes left. I would love to spend that time talking to you about this dice example. I can tell from just walking around and peeking over some people's shoulders. I saw a lot of you run it through the same process that I just did with the the gambling example one, and I think that's very smart. I think that's that's exactly what I was hoping people would do. Whoops, that's not what I meant to do. I wanted to refactor this. Rename it to something a bit more noun-like. Dice is plural, by the way. That's actually not a good class name. Having plural things typically frowned upon. This is a singular dice simulation. So, if you started here and then probably recognize that, these seem like they should probably be instance variables, and this also too probably seems like it should be instance variables, right? You're not wrong. I think that's an excellent way to start inserting some objects into the mix. But let me ask you a question. Did anybody come up with any other objects? Did anybody use more than one class to solve this problem? Okay. I would encourage you to push yourself and think about what other objects could be included here. It might seem like a bit of a stretch to even make that suggestion, considering that there's even less code here than there was in the previous example, right? But think about the nouns. Think about the things that are being mentioned over and over and over again in this example. I think there are some potential for some other objects. I think before we get to that, though, we probably need to finish doing, the simulation example, similar to the one from last time. It shouldn't take me too long to get that up and running, and then we can talk about some other objects. I'm going to add in, not print, private, the throw table and the frequency of sums. I don't know why I'm typing this stuff when I can copy it. Do it a lot faster that way. We'll have to set up a constructor real quick, just like we did in the prior example. We're not messing with scanner this time, which kind of makes it a little bit more straightforward. That also probably means that we want the dice per throw and the number of throws to come in as parameters to the constructor. And once we have those, that's enough for us to initialize the throw table and the frequency table. After I finish initializing all of these variables. This dot number of throws is number of throws. Okay. And then we just need the frequency, which somebody pointed out to me is there's a bug. Multiple somebodies have pointed out to me, I believe, that there is a bug in how this is computed. If it's a 6-sided die, and I'm throwing 7 dice minus dice per, is that not? No, it would just be this, wouldn't it? I guess it depends on how you're adding it up, because technically if I roll all ones, the lowest number that I could have is, the dice per throw. So I think that might be what this is trying to reflect. I honestly don't remember, and I'm honestly not too interested in chasing down those bugs right this second. I'm interested in talking about the objects. So let me proceed along with the objects. You can see I've already started doing some of the fun part, right? Extracting stuff out of main that we don't need anymore because the constructor's doing it. We can also come down here and start, just like last time, creating our dice simulation object. I think we did, what was it? 4 dice and 7 throws or something like that. Doesn't really matter. And now we get to do the fun part. Just like we did before, all these parameters are likely not needed anymore. They're instance variables, so I can extract them out, make the methods non-static. This is satisfying. This is genuinely enjoyable to me to do. Just makes me feel better. The throw number needs to remain because it is a parameter being passed in as part of the loop. So there is, at least one parameter that's necessary to keep down here, but a lot of these other ones can go. So if it relates to an instance variable, it can go, but if it doesn't relate to an instance variable, like there is no instance variable for throw number, so that probably needs to remain, at least for now, until we can do something else about it. And let's see what other errors I have to fix now that I've extracted that. Oh, there's one more static method down here that I would like to make non-static and remove the parameters of. Don't need this anymore. Do I need the die number? I guess I probably do need the die number still as well. Okay. Cool. Yeah, that all seems to be good. There's still some stuff in the main method that looks like it's unhappy. This is probably where I need to replace this by calling I need to call the instance, right? Simulator dot play dice game, and then remove these parameters that are no longer necessary. And then for this one, oh, so here you can see I'm trying to access one of the instance variables, but I can't do that from within main. So the indication here is that I should probably extract this stuff out into a method, not within the, should not have this stuff within main, but should have this be a method within my dice simulation class. So let's actually extract that out. That method would probably be called print frequency table or something along those lines. I can paste that code in there, and if I want to, put that up here, I can say simulator.print frequencies. There we go. Missing a parenthesis. All right, I believe I fixed all the errors. I believe I have, effectively turned this code into the object-oriented style as opposed to the procedural style that it was before. But let's return to this. Why are you upset? Dice per throw and is never used. That's interesting to me. Oh, because it's actually using the length of the table. Yeah, interesting. It's actually using the length. So we actually never that's interesting. So we can, cool. I don't know if I like that though. Is it better to have these named values and refer to the named values? I think that's a somewhat interesting question, right? This is not quite as direct as saying, in order to use this effectively, I have to remember that the rows dimension of my throw table represents the number of throws, right? Whereas I could effectively just remove any of that knowledge from being necessary by referring to the instance variable. I think this is an improvement that should be made, personally. Even though we technically could eliminate those instance variables, I don't think that that's a good idea. Same thing down here. This should be dice per throw, right? However, I would actually go one step farther than that and say that what we really need to do is insert some more objects in the mix. There are, I think, at least 2 more objects that I would consider adding in. One I think is fairly simple to spot. The other one less so. Does anybody have some ideas, suggestions? Maybe you can read my mind a little bit and think about what one of the two objects might be? Yeah. So the throw table is a data structure, right? So what I'm trying to make more classes. So what classes would I create that represents the throw table? I think the throw table, if I'm going to keep it, is in the right spot. However, I do kind of have a problem with that throw table. I would actually like to create more classes to maybe deconstruct that throw table. Yeah. A die class is one of the two I was thinking of. This is, I think, maybe a little less necessary than some of the other options you could consider, but down here, this one is called roll die. Well, a die can roll itself. That's an object-oriented way of thinking about it, right? I don't need to roll the die can roll itself. So what would that look like? That would look like having a die class. That represents a singular die, right? What would the instance variables be? I mean, in this example, they're all six-sided dice, but there are other values that exist. The only thing I can really think of that as an instance variable is the number of sides that a dice is going to have. Otherwise, it's pretty straightforward, right? The constructor is probably going to take in that parameter. And I forgot to put a type here, didn't I? There we go. That helps. And then the real magic comes from the fact, of recognizing that, oh, I can roll the die, right? I'm going to have a roll method. What's this roll method going to do? It's going to try and replicate what I was doing in here before, where I'm doing this, right? I'm making a die roll like this. But now instead of having this hard-coded 6 in there as a magic number, I can actually use the number of sides to say what that is, right? And so maybe what I want to do is return that value. So maybe this should have a return type of int. Or, I don't know if this is actually is accurate enough, right? Think about playing a game. I know I'm getting kind of into the weeds here, but think about playing a game. I roll a die, it sits there on the table, and then I can look at it and say, hey, what's face up right now? What's the value? So maybe I need another instance variable that says current value of the dice, right? And then I store the dice roll there, and then I can have a getter that says, hey, tell me what the current value is, right? That would be even more effective still, I think, as an object. But even doing this is an improvement and allows us then to, if we think about how that affects our simulation, right? Now, instead of doing this, actually, I don't want this really here at all anymore. Or what am I going to store in the throw table? I'm going to construct a six-sided die and then roll it and store that value in the throw table instead. But actually, before I do that, let's talk a little bit more about the other object that I have in mind. I don't like the throw table. It exists because when we use this in the intro class, it's for the unit on arrays, and we're trying to get people used to using two-dimensional arrays. I actually don't think that this is a good use of two-dimensional arrays. Two-dimensional arrays are great for storing values that take a grid shape that are actually in 2 dimensions, but that's not really what we have here. I have a list of one thing, like not two things. I have a list of throws, and each throw contains a certain number of dies, right? A certain number of die. I would argue that there is a strong case to be made for a throw object. And to further illustrate that fact, consider what would a throw be able to do? A throw would be able to tell me what its sum is, right? A throw would be able to tell me if all of the dice roll the same value, if I got a Yahtzee. Those are behaviors that are currently happening in the simulation. The good object-oriented design says, no, actually those aren't related to simulation. Those are related to a throw. Let's make a throw object and offload that work into my throw object. And so, what would the instance variable be for a throw? It would probably be an array of dice, right? or an array of die, rather, would be the proper way to say it. And then for the constructor, you need to tell me how many dice. The simulation knows how many dice I want to throw, right? So when the simulation needs another throw, it can construct a throw object, tell me the number of dice that I want. You know, I can either assume 6-sided dice, or this might be a good case where, you know, if I don't tell you the number of sides I want, I'll assume 6, but maybe I'll make another constructor down here, right? That also allows me to specify the number of sides if I want to vary that. And then I can adjust the size of the dice if I want to as well. I think that would be a good use of multiple constructors. But up here, I'd probably just say, you know, dice is equal to new die array, using the number of dice as the size. I would probably actually take this one step further. I think it's maybe somewhat debatable whether this should be done here or elsewhere. I think I like to do it better here. Remember, I'm creating an empty array. I need to actually put dice in that array. I need to create die objects and put it into that array. So when should I do that? Should I do that now as part of the constructor? Or should I do that later when I'm actually getting ready to throw the dice? I think it's probably better to do it now, because consider I'm gonna have a method down here called throw, right? And that's gonna go through and roll all the dice. So I think by the time I get here, the dice need to already be created. That's how it works in my mind. If you disagree, you're allowed, right? That's, I think, kind of the other part of coding, is that there's not one right answer. You're allowed to have disagreements. You're allowed to approach designs in a different way. But I'm going to specify what I think is logical in my head, and if you disagree with me, then bring your implementation into my office sometime. We can chat about it. That would be great. I'm just going to go through and make a 6-sided die. This doesn't actually roll any of them, right? This is just saying that they exist. And then when I get down here to the throw, what am I actually doing? I'm going to go through. Oops, that's the constructor. That's not what I meant to do. I meant to do this one. And actually, this is a bad word because this is used for exceptions. You can see it's purple, so it doesn't like that. So we need to change it a little bit, I guess, to throw all dice or something like that. Yeah, this is a great spot for like a for-each loop or something, I think. Oops. For every die that exists in our array, tell it to roll. And then I'm running out of time, so I'm not going to have time to fully code this up. But you know, just to kind of wrap up this example a little bit, I would want to have another method in this called getSumOfDice, which is going to, you know, just iterate through and tally up the sum of the dice. I would have another one that says, you know, public Boolean all dice equal, right? It's going to go through and check to see, is the value of all the dice equal? Did I roll a Yahtzee, right? We have that code already. It's in the simulation class, but now that I've successfully created this object, identified this need for the object, I can get it out of there. Let the simulation not worry about that stuff. Put it in here. It's going to be more organized, better object-oriented design. I don't have time to do that now, but I would really encourage you to give that a shot. Try it out, see how it feels. I think it feels good, honestly, to rewrite code, make it look nice and pretty. But that's all the time I have for today. We're going to tie up some loose ends next time and talk about the next homework assignment next time, but I hope you all have a good week. Let me know if you need any help getting assignment 3 finished up, okay? I'll see you on Wednesday.